Welcome back to another 3 steps to sketch on function transformations. In this video, we're going to look at a more advanced transformation of a general form equation, and we're actually going to look at it using both of our methods. So we'll look at it first with the table method, and then we'll look at the same transformation but using the on the graph method. And this will let you see how both of them work, but also what advantages each has. And so you can choose for future problems which would be best for you to use. All right, so let's jump into the table method. We have our 3 steps to sketch outline on the left, and we have everything else we need on the right. So we're given the graph y equals f of x in purple. We have our blank table, and we are transforming the purple graph to become y equals negative 3 f of 2x plus 6, close parentheses, minus 1. So that's a lot of transformations going on. It's pretty clear to see. And let's go ahead and jump into our method. And we'll start with step 1 by analyzing all of these transformations. All right, so let's look at our horizontal or x affecting transformations first. So that's everything that appears in the parentheses. And remember that we want to think of solving order when applying our horizontal transformations. This will allow us to make sure we apply them in the correct order to get the correct graph. So what we want to do is, over to the side, let's write out some scratch. So here are our 2 horizontal transformations, everything in the parentheses, and let's set them equal to 0 because this will help us know which one to do first. This solving order is our guide. And so if we were solving this equation for x, we know we would first start by subtracting 6. So that's exactly what we're going to do as our first transformation. So we'll do it over here in our equation, but what we really want to do is record it on step 1 horizontal transformation. Our first one is to subtract 6 from all the x's, and that will result in a movement left 6. So you can write left 6, or even better for our table, you can write x minus 6. All right, so back to our scratchwork equation. If we subtracted 6 from both sides, our updated equation would look like this. And then, of course, we would divide by 2. So this is a horizontal compression. Okay, so just to finish that out for completeness sake, we would have x equals negative 3. All right, so our second transformation to apply to our graph is to divide all our x's by 2, or compress by 2. All right, we'll write that as x divided by 2. Okay, so that's how we'll apply our horizontal transformations. Next, let's look at our vertical transformations. So these affect our y coordinates, and they happen outside of the parentheses, so everything else. And remember, when we apply these transformations, you should think PEMDAS order. All right, so first we have this negative 3 out front of the f. Okay, that will be our first, and it's actually a 2-for-1 type transformation. It's our first vertical transformation, and we're actually stretching out by a factor of 3, and the negative, remember, reflects the graph vertically, so that'll be a reflection over the x-axis. So let's note that down. We're going to stretch by a factor of 3, and I'm going to put slash capital R x, which just stands for that reflection over the x-axis. And even better, in our table, we're just going to do negative 3 times all our y's. All right, then our last piece, this minus 1 at the very end, something easy for the end, we're going to move down 1, or subtract 1 from all our y's. All right, so now we have everything analyzed. We have a good idea what this graph is going to be doing. And hopefully you're already looking at this thinking, okay, well, this M is reflecting vertically or flipping vertically, so it should end up looking more like a W shape when we get our finished graph. So just some nice things to have in your mind, some analysis. All right, we're ready to move on to step 2. Let's make our table and transform. So we're going to take our 5 major points from this given graph, and we'll insert them into our table. So we're starting with our first point, the one on the left, negative 4, 0. Then we have negative 3, 3. We have negative 2, 1, negative 1, 3, and 0, 0. All right, so now we're going to make a new column for each transformation, and we'll go through these one at a time, and that will lead us to our finished graph. So let's start with our horizontal. We know we're going to have two new columns, and we're going to work out. So first we'll apply the left 6, or x's minus 6, and then we'll apply the x's divided by 2. Okay, so first we're subtracting 6 from all those x's. So for example, negative 4 minus 6, so negative 10. All right, negative 9, negative 8, negative 7, and negative 6. Okay, so we've done the first horizontal transformation, and now we work from that new column that we've created, the x minus 6 column, and we're going to divide all those x's by 2. So negative 10 divided by 2, negative 5. We'll have negative 9 halves, negative 4, negative 7 halves, and negative 3. Okay, so we've completed both of our horizontal transformations. Now let's move on to our vertical transformations. All right, we've got our two columns. We know first we're applying the stretch and reflection. That's negative 3y. Let's write that a little neater. Negative 3y. All right, so 0 times negative 3, of course, is still 0, and we go through and multiply all of these y's by negative 3. So that's both stretching and reflecting them over the x. All right. And now we're ready to finish up with our shift. So we just finished our stretch and reflection. Let's move this new column of y's down 1, or subtract 1. All right. So now we have applied all of our transformations. At this point, we're really ready to move on to our third and final step, where we plot our points and sketch our graph. And the table method is great because your outermost columns are going to be your coordinates. So we'll have a point, for example, negative 5, negative 1 on our graph. That's that first point finally transformed. So it's really easy as just plotting once you have the whole table made. All right, so we'll plot negative 5, negative 1. We'll plot negative 9 halves, or negative 4 and a half, negative 10, our third point, negative 4, negative 4, our fourth, negative 7 halves, negative 10, and our final point, negative 3, negative 1. All right, so you can kind of see that double U shape being created, and that should help us sketch in our final graph. All right, so there you have it, a very advanced transformation of our given graph. So that was using our table method. Let's go ahead and look at the same problem, but this time we're going to use the on the graph method. So we'll have some intermediate graphs, and this is great because we'll get to see the graph being transformed in action. It gives a good visual. All right, so we'll go through the steps as if we have not worked this problem before, but know that it should match the result from the previous. All right, we have our steps on the left, what we need about the graph and the transformed graph on the right, and our first step is to analyze our transformations. So starting with our horizontal transformations, everything that appears in the parentheses of the f. So we'll write out all those transformations, the 2x plus 6, and we set it equal to 0. We know these transformations only affect the x coordinates, and we should apply them in solving order. So just as if we were solving this little mini equation that we've made up. All right, so we know we'd first start by subtracting 6 from this equation. So that tells us that we should have our x's and then take away 6, or move left by 6 units. So that's our first horizontal transformation. Left 6, or your x's minus 6. Okay, and then looking back at that scratch equation, to finish solving for x, we know we would divide by 2. And we don't really even need to finish that. This is a horizontal compression happening. So it compresses by a factor of 2, and that's your x's divided by 2. All right, so that's what's going on horizontally. Now let's look at our vertical transformations. So that's everything outside of the parentheses of f, and we know that these transformations affect the y coordinates. And we should apply them in PEMDAS order. So let's start with this -3 out front. So that's really a 2-for-1 transformation. We talked about that already. It both stretches vertically and reflects vertically, so over the x-axis. So we can say stretches by 3 and, as shorthand, reflects over the x-axis. Or that's really -3 times all your y values. Okay, and then our last transformation is this -1 at the end. So that's pretty straightforward. We're moving down 1, or y minus 1. All right, so now we have our analysis, and we are ready to move on to step 2. So step 2, plot and transform. Well, the graph was given to us, so we don't even have to plot. But we are ready to transform. So we're going to make intermediates and go step by step, applying the transformations in the proper order until we reach the final graph. So I'm going to use different colors and X's to mark the intermediates. As you practice this more, this method will get, I think, easier and easier. And you may even combine certain transformation steps and have less intermediate graphs. But it's completely up to you how you do it. Different colors is a great tip to keep all of your intermediate points straight. All right, so let's start by moving our graph left 6, our first horizontal transformation. So take each of your points. So I'll refer to them as point 1, point 2, point 3, point 4, point 5. I'm not going to keep those on there, but just for ease of mentioning. Okay, so take your first point and move it left 6, and we'll put an intermediate x. So move each point, second point, third point, fourth, and fifth. And you can kind of see, we won't sketch in the actual graph, but you can see how this has moved the purple graph to the left 6. So now let's change colors for the next transformation. Okay, so we're going to take all of the x's and we're dividing them by 2, or we're halving their distance into the y-axis is another way to think of it. So point 1 is at -10, and it should now end up at -5. All right, point 2 is at -9. It should end up at -4.5 or -9/2, which should feel familiar if you listened to the table. I think you can see some nice parallels here, some nice commonalities. Okay, point 3 is at -8. The y-coordinate doesn't change. All we're doing is halving the x-coordinate, so it ends up at -4, 1. All right, fourth point, it's at -7, so it ends up at -3.5 or -7/2. And finally, the fifth point comes in, halving -6 to be -3. All right, so you can see it's the same shape. It's still that M shape. However, it's now compressed in a horizontal direction. All right, let's switch colors. Okay, so we're on to our vertical transformations now. Let's go ahead. I'm going to check off the other two in the colors that we used just so we can see what happened here. So we did the first horizontal in green, the second in blue, and let's do the third in yellow. So we're working from our blue graph now, and we want to apply the stretch, the vertical stretch, and the reflection. And this goes together, so you can do this in one move. So it doesn't matter. You can reflect and then stretch, or you could stretch then reflect. You'll get the same result. So starting with point 1, well, stretching a y-coordinate of 0 doesn't do anything, and reflecting over the x doesn't do anything because it's on the x-axis, so it's going to stay put. All right, second point is much more interesting. The y-coordinate's 3, so you can either multiply it by 3 first, moves up to 9, then reflects. You could reflect it and then multiply it by 3, or honestly, just multiply it by -3, and you'll accomplish that in both of those things in one move. So you'll end up with -9, and the x-coordinate does not change. It stays put at -4.5. All right, third point, y-coordinate of 1 becomes a y-coordinate of -3. X doesn't change. Fourth comes down to -9, just like the second. And the last stays like the first. It's on the axis, so stretching and reflecting, they don't affect this point at all. Okay, check that one off. And let's change to a final color. All right, so we'll do this final transformation in red. It's a very easy one to finish, and we'll actually darken these points. We'll do step 3. We'll darken and sketch the graph. So move each of the yellow points down 1. All right, that was easy enough. A great way to finish. It's nice to save that vertical shift for last. And all you have to do is connect the points. And you see we have the exact same graph that we made with the previous method, with the table method. But we saw these intermediate shapes as we went along versus having them numerically in a table. So when you have a lot, sometimes people prefer a table. Other people really like the visual and following the movements. Both work great. You get the same result. So try them out and see which works the best for you.